All right, let's take a look at our practice test. We're told to solve each equation. And for the first problem, we're going to look at 1 over x squared plus 10x plus 25. This is going to be set equal to 1 over x plus 5. Then minus, we have 2 over x squared plus 10x plus 25. Now, the idea with this type of problem, we're solving an equation with rational expressions involved. So we borrow a trick from when we solve equations with fractions. We first figure out what is the LCD or least common denominator. We know how to do that. And then we would multiply both sides of the equation by that LCD to clear all the denominators. The problem that comes up is that in some cases, when you multiply both sides of an equation by either a variable or you could say a variable expression, you might get extraneous solutions. Okay, so extraneous solutions are solutions that work in the new equation that's formed, but they do not work in the original. So sometimes that'll happen, and basically you just need to check your domain. So does the result you get, or the solution for x, if you plug that back in, do you get a rational expression where you're dividing by 0? Okay, so that's what you're checking for. So looking at this guy, first off, I would just factor everything. So this x squared plus 10x plus 25, which occurs here and also here, that is a perfect square trinomial. So that can be factored into x plus 5 quantity squared. So let's write 1 over x plus 5 quantity squared. And this equals, you have 1 over x plus 5. And then minus, we have 2 over, again, we'll have that x plus 5 quantity squared. Now, in terms of the LCD, you would look at your denominators. So you have x plus 5 quantity squared, you have x plus 5, and then you have x plus 5 quantity squared. So it's the same factor involved, but again, you're going to go with the highest number of repeats between any of these guys. So here it's a 2, here it's a 1, and here it's a 2. So the highest number of repeats is a 2, or in other words, our LCD would be the quantity x plus 5 being squared. So I'm going to multiply both sides of the equation by that LCD, and that will clear all of my denominators. So let's write this real small so we can fit it. I'll just say that we have x plus 5 quantity squared multiplied by 1 over this quantity x plus 5 being squared. Then this equals, we're going to have x plus 5 quantity squared times 1 over x plus 5. And you could wrap this in parentheses if you want, just for clarity. You don't have to, though. It's up to you. Then minus, you'll have 2 over. You have this x plus 5 quantity squared. And then this is times your x plus 5 quantity squared. Okay, so let's go through and cancel some things. So this would cancel with this. And then basically one of these, let me put a 1 there, would cancel with this. And then this would cancel with this. So I'm just going to take what I have. So it's going to be this, and then it's going to be this times this, and then I'm going to have this. Okay, so whenever you do this and you have a lot of canceling, you really have to pay attention to what's left. Sometimes you can skip something and get the wrong answer. So over here it's just a 1, and this is equal to, over here it's x plus 5. Remember, we canceled this out. Now there's a 1. So it's just x plus 5, and this is multiplied by 1. So anything times 1 is itself. So this is just x plus 5. Then over here we have a minus, and then just a 2. Okay, so we'll just solve this equation real quick, and then we'll come back up and check. So let's write 1 is equal to x, and then 5 minus 2 is 3, so plus 3 there. And then to solve this, let's just subtract 3 away from each side, cancel that away. So this would be negative 2 is equal to x, or I would flip it around because I like my variable on the left. So I'll say x is equal to negative 2. Okay, so coming back, you want to check to make sure, first and foremost, that you don't have a domain violation. So in other words, what is the domain when we consider this guy? When you think about all your denominators, you would set each one of them equal to 0 and solve. Now in this case, you have a perfect square trinomial that factored into a binomial squared. So this x plus 5, you would set that equal to 0. You would solve that. You get x is equal to negative 5. So here for the domain, let me write this off to the side so nobody's confused. We'll put that the domain is going to be the set of all x such that x is not equal to negative 5. And I think you can see that if you plugged in a negative 5 here, negative 5 plus 5 is 0, 0 squared is 0. So you'd be dividing by 0. Here, negative 5 plus 5 is 0. Here, negative 5 plus 5 again is 0, and 0 squared is 0. So that's our domain, the set of all x such that x is not equal to negative 5. Now, if you're on a timed exam, I would just make sure that this guy right here, this x equals negative 2, does not violate the domain, right? So in this case, it does not. So you would move on with your test and maybe come back later and check for the simple mistakes that we often make when we're solving equations. I'm just going to go through, since we don't have a time limit here, and plug in, show you that the left and the right sides are equal. You can always skip this part if you don't need it. So I would plug in a negative 2 here, and then also here, and then also here. So over here, negative 2 plus 5 is 3. So we'd have 1 over 3 squared, which is basically 1/9. So let's just erase this and put 1/9. Over here, negative 2 plus 5 is going to be 3. So let's put 1/3 there. Over here, negative 2 plus 5 is 3. 3 squared is 9. So this is 2/9 here. So you would need to get a common denominator. You'd multiply this by 3 over 3. So this would be 3/9. So 3/9. And then minus 2/9. So 3 minus 2 would be 1 over the common denominator of 9. So we can see that we get the same value of 1/9 on the left as we get on the right. So this is a valid solution, right? It does not violate the domain, and the left and the right sides are equal. All right, let's take a look at problem number 2 now. So we have 1 over x plus 1 is equal to 5 over x plus 1 plus x plus 7 over x squared plus x. Okay, so I'm just going to rewrite this. So 1 over your x plus 1 is equal to 5 over your x plus 1. And then plus, I'm going to have this x plus 7. I'm going to factor this denominator so I can pull out an x. And that's going to give me the quantity x plus 1. So when I'm finding the LCD, remember, I'm going to think about each different denominator. So this one's x plus 1. This one's x plus 1. And this one has an x plus 1. So that's common to everything. And there's only one that occurs each time. So that's going to go in. Then I have this x here that's only going to be for this one. But again, it's got to go in. Okay, so I'm going to put my LCD as this guy right here. So this x times the quantity x plus 1. So this is what I'm going to multiply both sides of the equation by to clear all the denominators. So we have x times the quantity x plus 1. And that's going to be multiplied by 1 over x plus 1. This equals 5 over x plus 1. Again, times this x times the quantity x plus 1. Then plus, we have x plus 7 over x times the quantity x plus 1. And this is times x times the quantity x plus 1. Let's cancel this with this. And you can wrap this in parentheses if you need to. It's not necessary, but some people like that. Let me wrap this as well. So I'm going to cancel this with this. And then I'm going to cancel this with this. So the x's would cancel. And then this with this. Okay. What do I have left? And again, this is tricky because sometimes you think this whole thing is canceled, but you still have this x here and you have this 1 here. So you have to be really, really careful when you solve these types of problems. So this is going to be x times 1 or just x is equal to, this is 5 times x, so that's 5x. And then plus, over here you have this x plus 7, and that's it. Everything else is canceled away. So x plus 7. Okay, so what does this give me? Well, 5x plus x is 6x. So let's say that x is equal to 6x plus 7. Let's subtract 6x away from each side and cancel this away. This would be negative 5x is equal to 7. Let's divide both sides of the equation by negative 5. Let's cancel this, and we'll say x is equal to negative 7/5. Now, one thing you could do when you start getting all these different fractions involved, you can divide this in your calculator. You're going to get negative 1.4, so that's the decimal answer. And that might be easier to work with because when you work with fractions, obviously you have to get all these common denominators and that takes time. But again, let's first think about the domain and whether this violates it or not. So here you have x plus 1, here you have x plus 1, here you have x plus 1. So you set x plus 1 equal to 0 and you solve that. So we know that x cannot be negative 1. But also you have this x hanging out right there. So you have to set that equal to 0 as well. And that would just be x equals 0, right? So if you plug in a negative 1 or a 0, for x, you would end up with division by 0. And again, that's undefined. So we would say that our domain here is the set of all x. So let me write that in there. I just need to slide this down. So again, the set of all x such that x is not equal to negative 1 or 0. So let's close that. And then essentially I would just plug this in to make sure that I didn't make an error. Right now I know that I didn't violate the domain. So again, if I'm on a timed exam and I just want to go through it quickly, well then I would just say, okay, this does not violate the domain. So I would just move on. But just for completeness, let's plug in a negative 1.4. And then I'll make a little border there. So you'd have 1 over, again, I'm just going to use negative 1.4. And if I add that to 1, I'm going to get negative 0.4. Then this equals, you have 5 over negative 1.4 plus 1, again, is negative 0.4. And then plus, you have this negative 1.4 plus 7 over, you have negative 1.4. times your negative 1.4 plus 1. And again, this is going to be negative 0.4. So this guy right there. So this is something I would just do with a calculator really quickly. 1 divided by negative 0.4, that's going to be negative 2.5. So this is negative 2.5. Or if you were working with fractions, you would have got negative 5/2. Then over here, 5 divided by negative 0.4, that's negative 12.5. So let's say this is negative 12.5. And then over here, negative 1.4 plus 7, that's 5.6. And then over here, negative 1.4 times negative 0.4, that's going to be 0.56. So 0.56. If you do this division here, you're going to get 10. So let's erase this and put 10. And then negative 12.5 plus 10 is going to give me that negative 2.5. So you get negative 2.5 is equal to negative 2.5. Or again, if you were working with the fractions, you get negative 5 halves equals negative 5 halves. But again, that's going to take a lot longer because you do have to get common denominators. Either way, this answer here, which is x equals negative 7/5, or you could say x equals negative 1.4, that solution is correct. All right, let's take a look at problem number 3 now. So we have x plus 2 over x squared minus 3x. Then plus we have 7 over x, and this equals 1 over x minus 3. So the idea is I'm just going to factor this denominator here. So I'll say this is x plus 2 over x times the quantity x minus 3. Then plus I'll have 7 over x. Can't do anything with that denominator. Then this equals 1 over x minus 3. Can't do anything with that denominator. Okay. Looking at this guy, this has an x here, and this has an x here. Then this has an x minus 3 here, and this has an x minus 3 here. So the LCD would just be the x times the quantity x minus 3. So let me actually put a box around this. I'm just going to multiply both sides of the equation by that so I can clear all my denominators. So let's say we have x plus 2 over x times the quantity x minus 3. And then this is times x times the quantity x minus 3. Then plus 7 over x times x times the quantity x minus 3. And this equals 1 over x minus 3 times your x times the quantity x minus 3. Okay, let me actually wrap this, and I'm going to wrap this just for clarity. It's not necessary, but a lot of students need it. So I'm going to cancel this out with this out, right? X divided by x is 1. The quantity x minus 3 divided by the quantity x minus 3 is 1. So that's gone. Then this is going to cancel with this. Again, you could wrap this in parentheses if you want. It's really personal preference. Then this is going to cancel with this. Okay, what's left? Over here, it's x plus 2. So x plus 2. Then plus. Here, it's 7 times the quantity x minus 3. You have to keep the 7 out in front of those parentheses because the 7 needs to multiply by the x and then the negative 3. A very common mistake when you solve this type of problem is to just say it's 7x minus 3, and the 7 needs to multiply by both. Okay, so it's very important. Then this equals, you have 1 multiplied by x, which is just x. So I'm just going to say this is x plus 2 plus 7 times x is 7x, and then minus 7 times 3 is 21, and this equals x. So let's combine like terms here. X plus 7x is 8x, and then 2 minus 21 is negative 19, and this equals x. So what I'll do is subtract x away from each side, and I'll add 19 to both sides. And so let's cancel this away and cancel this away. I'll have 8x minus x, which is 7x, and this equals 19. Okay, let's divide both sides of the equation by 7, and we'll cancel this 7 with this 7 and say x is equal to 19 sevenths. Okay, coming back up here, again, you could just make sure it doesn't violate the domain, or you could check it completely. I'm going to do both. So I'm just going to say that my domain here is found. So it's the set of all x such that, well, you have this factor of x, so you need to set that equal to 0, and basically that's your x is not equal to 0 there. That's pretty simple. Then the other guy is x minus 3, so set that equal to 0. If you solve that, you get x is equal to 3. So x can't be 0 or 3, right? In either case, if you plugged in a 0, you would get a denominator here and a denominator here, which is 0, right? You'd be dividing by 0, which is undefined. And then if x was 3, then this denominator here and this denominator here would be 0. And again, division by 0 is undefined. So these are our two restricted values, this 0 and 3. So our domain is the set of all x such that x is not 0 or 3. Now 19 sevenths, that doesn't violate anything. So again, if you're in a hurry, just put that down and move on. But let's go ahead and check this for those that want to. And for this one, if you divide 19 by 7 in your calculator, you're going to get a pretty nasty decimal. It's a repeating decimal. So I would probably just go through and get common denominators here and just stick it out. So this would be 19 over 7 plus 2. So that's going to be 14 over 7. So 14 over 7. And all I did was multiply 2 by 7 over 7. So 19 plus 14, that's 33. So this top part here is 33 over 7. Down here, you have 19 over 7. Let me do this off to the side. So we have 19 over 7 times your quantity, 19 over 7 minus, for 3, I'm going to write that as 21 over 7. So this is going to be negative 2 over 7. So this is negative 2 over 7. And if I multiply 19 times negative 2, I get negative 38, and 7 times 7 is 49. So this would be negative 38 over 49. So this is divided by negative 38 over 49. So I'm just writing it with the division symbol here versus the fraction bar. And we know that we're going to take this first guy, which is 33 over 7, and multiply by the reciprocal of this guy, so 49 over negative 38. So then I'm going to cancel this with this and say this is a 7. And that's basically all I can do. So I would say 33 times 7 is 231, and this is over basically 1 times negative 38, which is negative 38. Okay, let's erase all this. So now we have plus, we have 7 over this 19 over 7. So again, you could write this as 7 divided by your 19 over 7 like this. So you could go 7 over 1. And then all you'd have to do is multiply by the reciprocal. So you'd flip this and say this is 7 over 19. And so this gives me 49 over 19. So this is 49 over 19. And this equals, over here you'd have 1 over. So you have x, which is 19 over 7. So 19 over 7, and then minus 3. Again, we did that before. That's 21 over 7. So 19 minus 21 is negative 2. So this is negative 2 over 7. So negative 2 over 7. Now with this 1 being divided by this, you could just take the reciprocal of this negative 2 sevenths. So this is negative 7 halves there. And so that's what we're looking for this side to be equal to. So at this point, I could just multiply this by 2 over 2. So 49 times 2 is 98. So this would be 98. And 19 times 2 is going to be 38. Okay. What I'll do is move this negative up here. So negative 231 plus 98, that's negative 133. So basically, what you'd want to do is reduce this guy. And if you cancel a common factor of 19 between the numerator and denominator, you're going to end up with negative 7 halves. So I know this took forever, but we did verify our solution. So x equals 19 over 7. All right, let's take a look at problem number 4 now. So here we have 4 over 5x plus 7. Then minus, we have 6 over 5x cubed plus 52x squared plus 63x. This is equal to, we have x plus 3 over 5x cubed plus 52x squared plus 63x. So this one is a bit tedious, but I think it's good to have an example like this. So the first thing you would do is obviously factor this 5x cubed plus 52x squared plus 63x. Okay, let me write that out. So 5x cubed plus 52x squared plus 63x. Well, the first thing is, can I pull anything out? Well, if you look at 5, that's a prime number. And then you go to 52, that's not divisible by 5, so you can stop there. But you do have an x cubed, an x squared, and then an x. So I could pull out an x. So let me start by just doing that. So I'm just going to say this is x times, inside I'll have 5x squared, and then plus I'll have 52x, and then plus 63. Okay, from here, what I'm going to do is say I have my x outside. Let me set up my parentheses here. And again, 5 is a prime number, so that actually works to our benefit. So I'm just going to say this is 5x and this is x. Now, for 63, it's really not that bad. It's either 1 times 63, or it's 9 times 7, or it's 3 times 21. So really, there's only 3 things you need to check. So 1 in 63, that's not going to work because, again, you're going to have all plus signs here because everything's a plus. If you put the 63 here, it's too big, and it's also too big if you put it here. So that's out. So then you would have 9 and 7. So would that work? If you put a 9 here and a 7 here, your outer is going to be 45x and your inner is going to be 7x. Well, 45x plus 7x is 52x. Okay, so this is our factorization of this guy. Let me erase everything. And I'm going to have to write this really, really small to fit everything on the screen. 4 over 5x plus 7. And then minus, you'll have 6 over this guy right here. So x times the quantity 5x plus your 7 times the quantity x plus 9. And then we'll say this is equal to, you have this x plus 3 over, you have x times the quantity 5x plus 7, and then times the quantity x plus 9. Okay, let's extend that a little bit. All right, let's get rid of this. And now let's think about our LCD. If we look across here, we have this 5x plus 7, which is here and here and also here. So we know that goes in. Then also we have this x, which is here and here, so that goes in. And then we have this x plus 9 here and here, so that goes in. So the LCD, let me just put a box around this one. The LCD is this guy right here. Obviously, it's also this guy right here. Now, trying to fit this on the screen is really, really difficult. But basically, you're going to take this guy right here, this LCD, and multiply it by each guy in the equation. So we know that in this case and in this case, the denominators are going to cancel completely. And so for here, you're going to have -6, and here you're going to have x plus 3. Okay, so I'm just going to do this one first over here. That way I can do it the long way. And then we know it's going to cancel over here. So 4 over 5x plus 7, and then times this x times the quantity 5x plus 7 times the quantity x plus 9. And so basically this would cancel with this. And so you would have 4x times the quantity x plus 9. Okay, let me write that up here. And then I'm going to go minus. Again, this would cancel completely, right? So we don't have to write that out. We know it's just -6. And this equals, this would cancel completely. So you're just going to have the x plus 3. Okay. So from here, it's not that bad. We're just going to end up with a quadratic that we have to solve. So this is going to be 4x times x, that's 4x squared. And then plus 4x times 9 is going to be 36x. And then -6 is equal to x plus 3. I want to subtract 3 away from each side and cancel this. I want to subtract x away from each side and cancel this. Let's put a 0 over here. Let's say this is 4x squared. And then 36x minus x is 35x, so plus 35x. And then -6 minus 3 is -9, and this equals 0. All right, so can we solve this using factoring? I think we should give it a shot. If you're not comfortable with this, again, you can just use the quadratic formula. So let me set this up here. I'm just going to use reverse FOIL. Again, you could also use the AC method if you want. Now, 4 is not a prime number. It's either 1 times 4 or 2 times 2. I would start with 4x and x and see if I can make that work. This is a minus here, so I'm going to need to subtract. Again, in terms of absolute value, I'm trying to get to 35, okay? So 9 is either 1 times 9 or it's 3 times 3. So if you put the 9 here and the 1 here, you're going to see that this is going to work right away, right? So basically, if you make this a positive and this a negative, then this is going to be 36x, and this is going to be minus x. So 36x minus x is 35x. So this is our factorization. So sometimes we get lucky and we get it right away, and other times we have to go through all of the possibilities before we find it. So this is going to be 4x minus 1 is equal to 0, or x plus 9 is equal to 0. So let's add 1 to both sides of the equation here. This will give me 4x is equal to 1. Divide both sides by 4. We'll cancel that and say x is 1/4. Over here, let's subtract 9 away from each side. We'll cancel this. So also x could be -9. Now again, we have to check these. Okay, so the first thing is we want to make sure we don't violate the domain. And then we could also check to make sure that the left and the right sides are equal. But again, you need to, at minimum, make sure you're not violating the domain. So the domain here is going to be the set of all x such that x is not equal to, well, first off, you have this x here. So you can think about this factor here. If you set that equal to 0, well, it's just x equals 0. So one value that x can't be is 0. Then the other guy is 5x plus 7. You'd have to set that equal to 0 and solve. Subtract 7 away from each side. Cancel this. You would have 5x is equal to -7. Divide both sides by 5. And so x can also not be -7/5. Then the last guy, we would take x plus 9 and set that equal to 0. And we would say that the solution there is x equals -9. Okay. So let's look through our solutions here, because again, the domain is a set of all x such that x is not 0, -7/5, or -9. Now, what do we see right here? We have a solution of -9. So we have to reject that solution. It's extraneous, right? So if you plugged in a -9 for x here or also here, what's going to happen is you get -9 plus 9, that's 0. And 0 times anything is 0. So you're going to end up dividing by 0 here and also here. And so we end up with something that's undefined. Okay, so again, we have to reject that solution. So the other solution is 1/4. So that does not violate the domain, so we just need to check that. So you're going to have 4 over your 5 times x. So this is 5 times 1/4, and then plus 7, and then minus 6 over. You have this 1/4 times this 5 times 1/4. And then basically plus 7, and then times, you're going to have this 1/4 plus 9 here. And let me just stop here. Let me figure out this side, and then I'll figure out this side. We'll be able to take this answer right here and share it with this one, so that'll speed up the process a little bit. Over here, 5 times 1/4 is 5/4. So this is 5/4, and then plus 7. So we'll need a common denominator. So let's say this is 28 over 4, and 5 plus 28 is going to be 33. So this is 33 over 4. Okay. For this guy right here, I can go ahead and say that this is 33 over 4, right? Because it's the same. The 5x plus 7 here is the same as the 5x plus 7 here. So let's just say this is 33 over 4. And then what I'll do is say 4 is multiplied by the reciprocal of this. So 4 is going to be multiplied by this 4 over 33. So that's 16 over 33. So this is 16 over 33. Okay, over here I'm going to write 9 as 36 over 4. And so this would be 37 over 4 if I do the addition. And let's see what we get. So 33 times 37, that's 1,221. So let's write that. So this is going to be 1,221. And then 4 times 4 times 4 is going to be 64. So this would be over 64. Okay, I'm going to share that answer with this over here. So I'm just going to write 1/4 plus 3 over here, and then over 1,221 over 64. Okay, so coming up here again, I just want to flip this. So I'm going to say 6 is multiplied by the reciprocal of this. So 6 times this 64 over 1,221. Let's get rid of this. And we know this is not an even number down here, but 1 plus 2 is 3, 3 plus 2 is 5, and 5 plus 1 is 6. So that tells me that this is divisible by 3, and so is this. If I divide this by 3, I'm going to get 407. And if I divide this by 3, I'm going to get 2. So basically, 2 times 64 is 128. So this is what we have over here. Let me slide this over. All right, now at this point, we need to get a common denominator. If you think about 33, it's going to be 3 times 11. So this is 3 times 11. For 407, 4 plus 0 plus 7 is 10. So you know it's not divisible by 3. But if you check to see if it's divisible by 11, you're going to see that it's 37 times 11. Okay, so the LCD would be what? It's 3 times 11 times 37. So 3 times 11 times 37, which is that 1,221 that we saw before. So I'm going to multiply this guy by what I need. So that's going to be 37 over 37. And then this guy is going to get multiplied by 3 over 3. Okay, let's get rid of this and let's see what we have. So 16 times 37, that's 592. So this is 592. And of course, 33 times 37 is 1,221. Then over here, 128 times 3, that's 384. And again, 407 times 3, that's 1,221. So this is 1,221. 592 minus 384, that's 208. So you would have 208 over 1,221. This guy right here, this 208 is going to be basically 16, or you could say 2 to the 4th power times 13. And this 1,221, that's going to be our 3 times 11 times 37. So we know there's nothing in common between the numerator and denominator, so that's going to be simplified. Okay, thinking about this over here, let me get rid of this equal sign, and I'll just bring this down a little bit. So 1/4 plus 3, let's just say this is 12/4 like this. And basically this would be 13/4. So let's say this is 13 over 4 times the reciprocal of this, which is 64 over 1,221. And let's see what this is going to give us. 64 divided by 4 is going to be 16. So this would be 16. And we just said that 16 times 13 is 208. So we see that this would be 208 over 1,221. So although it took forever, we see that the left side and the right sides are equal. So this is a valid solution. Again, if you get something that's this difficult to check, you can just use your calculator. Or if you want to do it the long way, I would wait until your test is over and then come back. As long as you didn't violate the domain here, you should be good as long as you didn't make a silly mistake. All right, let's take a look at problem number 5 now. So we have 3x minus 24 over x squared minus 6x. This is equal to 1 over x minus 6, then plus 1 over x. So what I'm going to do is just write this as 3 times the quantity x minus 8. I'm just going to factor the numerator just in case something cancels. Then this is over. Down here I'm going to have x times my quantity, x minus 6. Now, turns out nothing's going to cancel, but I'm just going to keep it in factored form. That's the way I like it. Then this equals, we're going to have 1 over x minus 6. And then plus 1 over x. Okay, what is the LCD here? Well, you see that here you have x and here you have x. Then here you have the quantity x minus 6 and here you have the quantity x minus 6. So your LCD is just going to be this guy right here, your x times your quantity x minus 6. Okay, so let's write 3 times the quantity x minus 8 and then over x times the quantity x minus 6 and then times x times the quantity x minus 6. Then this equals, you have 1 over x minus 6 times your x times your quantity x minus 6, then plus your 1 over x times your x times your quantity x minus 6. This will cancel with this, and so I'm left with this 3 times the quantity x minus 8. Now you can do that now if you want and just say this is 3x minus 24. Then this equals let me wrap this. This would cancel with this. So you have x times 1, which is just x. Then plus, this would cancel with this. And you have 1 times this quantity x minus 6, which is just x minus 6. Now to simplify, let's write 3x minus 24 is equal to x plus x is 2x, then minus 6. What I'll do is subtract 2x away from each side. Let's cancel that. And let's add 24 to both sides. Let's cancel that. So 3x minus 2x is x. That's equal to negative 6 plus 24. That's going to be 18. So x equals 18. That's our answer. Okay, so let's figure out, again, what is the domain and make sure that this guy is not going to violate it. So the set of all x such that x is not equal to. Well, in this case, you would set x equal to 0, so it's just 0. And then you would set x minus 6 equal to 0, so that's going to be a solution of x equals 6. So x here can't be 0 or 6. Again, plugging either of those in for x would result in a denominator that's 0, and again, division by 0 is undefined. So 18 does not violate the domain. So again, if you're in a hurry, you can just put that down as your answer and move on. But for completeness, I'm just going to plug it in and check, show you the left and the right sides are equal. So I'm going to say that 3 times a quantity, you would have 18 minus 8, which is 10. And 3 times 10 is 30. Let's just put that in there now. So let's just say this is 30. And this is over. You would have 18 times your quantity. 18 minus 6 is going to be 12. So before I multiply here, let's just cancel. 30 divided by 6 is 5. And then 18 divided by 6 is 3. So basically, this is 5 over 36. So let's write this as 5 over 36. This is equal to. Over here, you have 1 over. You have 18 minus 6, which is 12. And then plus 1 over, you have 18. Now, you would have to get a common denominator here. In the LCD, when you consider 12 and 18, this right here is basically 2 squared times 3. And this right here is 2 times 3 squared. So you need 4, or 2 squared, times 9, or 3 squared. So 36 is the LCD. So I'm going to multiply this by 2 over 2. And I'm going to multiply this by 3 over 3. And so you're going to get 3 over 36. So 3 over 36. And then plus, you're going to have 2 over 36. So 2 over 36. And obviously, this would be 5 over 36. So we have verified our answer here of x equals 18. Because again, the left and the right sides are equal. And of course, we do not have a domain violation here. All right, let's take a look at problem number 6. So here we have 1 is equal to 1 over x plus x squared minus 2x minus 3 over x squared plus 6x. Okay, the first thing I'm going to do is just factor everything that I can. So 1 is equal to 1 over x. And then plus, this guy up here, can I factor that? I need two integers whose sum is negative 2 and whose product is negative 3. X minus 3, that quantity, times the quantity x plus 1. And this would be over. Down here, I'm going to factor out the x, and I'll have x plus 6 inside the parentheses. Okay, nothing's going to cancel here, so I've checked that. And just looking at my LCD, we can see that there's an x here and an x here. And then here you have the x plus 6. So it's x times the quantity x plus 6. So this would be your LCD here. Now, I'm going to multiply both sides by this LCD. So this 1 multiplied by this would just give me this. So this is x times the quantity x plus 6. And this equals, over here, this would be 1 over x times this guy. So you just write it up here to save some space. So x times the quantity x plus 6. And then we're going to have plus, we'll have this x minus 3 times the quantity x plus 1 over your x times your quantity x plus 6. And this is multiplied by, again, x times the quantity x plus 6. Okay, so nothing to cancel over here. This is going to cancel with this. And then this is going to cancel with this. Okay, so over here, I'm just going to go back to that form of x squared plus 6x. And this equals, over here you have x plus 6. And then plus, here we're just going to undo what we did when we factored. So this is going to go back to x squared minus 2x and then minus 3. Looking at this now, you see that there's an x squared here and an x squared here. So I could subtract x squared away from each side of the equation. That would disappear. X minus 2x would be negative x. So let's say this is 6x is equal to negative x. And then 6 minus 3 would be 3, so plus 3. Let's add x to both sides. And we'll cancel this away. We'll say 7x is equal to 3. Let's divide both sides by 7. We'll cancel that and say x is equal to 3/7. Okay, so coming back, let me say my domain is what? The set of all x such that, well, here you have this x, right? So x can't be 0, so x is not 0. And then additionally, you would set x plus 6 equal to 0. You'd solve that, and x can't be negative 6. So x can't be 0 or negative 6. So again, set of all x such that x is not 0 or negative 6. That's your domain. And so 3/7 does not violate that, right? We're in the domain, so we're good to go there. Now trying to plug in a 3/7 for x here and here and here and here and here, it's going to be pretty tedious. I'm just going to tell you because you have to get a lot of common denominators. Now you could plug the whole thing in, the whole right side into your calculator. If you do it correctly and you wrap everything, you will get 1. Okay, so you can do it like that. It's really up to you. If I was on an exam, I'd probably do it that way just to check. But I think we could do it the long way just to get some practice. So we have 1 is equal to, now 1 divided by 3/7, you just flip that at 7/3. Then plus. Here you can have 3/7 minus 3. So let's do 3/7 minus 3. Then this is multiplied by 3/7 plus 1. Then this is over. You have 3/7 times your quantity 3/7 plus 6. So a lot of common denominators to get. So for this one, you basically have negative 21 over 7. And then for this one, it would be 7 over 7. And then for this one, it would be 42 over 7. And basically, let me make that a little bit better. So this is 42 over 7. You put that fraction bar back in there. So 3 minus 21 is going to be negative 18. So this is negative 18 over 7. So we have negative 18 over 7. And then basically for this one, 3 plus 7 is 10. So this is 10 over 7. So this is 10 over 7. So I can't cancel anything. So negative 18 times 10 is negative 180. And then 7 times 7 is 49. So this is negative 180 over 49. Down here, 3 plus 42 is 45. So this would be 45 over 7. And if I multiply here, nothing's going to cancel. So 3 times 45, that's 135. And that would be over 7 times 7, which is 49. So this is 135 over 49. Okay, we're going to take this guy and multiply by the reciprocal of this guy and see what we get. So let's get rid of this. So let's cancel this with this. Now 135 is going to be 5 times 3 cubed. And then 180 is going to be 2 squared times 3 squared and then times 5. Well, you would basically cancel a common factor of 5 and a common factor of 3 squared or 9. So essentially in the numerator, you're going to have a negative 4. So let's write negative 4. And in the denominator, you're going to have a 3 to the first power. So 3 to the first power. Let me actually get rid of this. So this is going to be negative 4/3 here. Okay. So if we have 7 plus negative 4, that's going to give me 3. And this would be over the common denominator of 3. And 3 over 3 is 1. So again, we verified our solution. I know it takes a while, but we verified that x equals 3/7 is valid. All right, let's take a look at problem 7. So we have x over 2x squared plus 10x plus 8, then minus x minus 7 over x plus 4, and this equals 1 over x plus 1. Let me just rewrite this. All right, so let me put x over. Before I factor this, notice that you could pull out a 2. It's going to make it a lot easier. So then you would have this x squared, and then plus 5x, and then plus 4. So this is 2 times the quantity. You'd have an x here and an x here. 2 integers that sum to 5 and have a product of 4. That's going to be 4 and then 1. Let's get rid of this, and then let's slide this up here. Okay. Then minus, you have x minus 7 over x plus 4. And then this equals 1 over x plus 1. Now, what's the LCD? You have a 2 here that's going to have to go in. You have this x plus 4 occurs here and here once each time. And then an x plus 1 that occurs here and here. So this guy right here is going to be your LCD, right? So this 2 times the quantity x plus 4 times the quantity x plus 1. So if I multiply both sides by the LCD, this is going to cancel, okay? So we're going to say that this is just x over here, then minus. So this is going to get multiplied by this right here. So let me write this one out. So x minus 7, I'm going to wrap this, and then this is over this x plus 4, and it's multiplied by this 2 times the quantity x plus 4 times the quantity x plus 1. Now to save space, because I'm not going to be able to fit this, I'm just going to cancel this with this, and I'm just going to get rid of it so that we have some room. Otherwise, we won't be able to fit this. So I'm just going to write this as 2 times the quantity x minus 7 times the quantity x plus 1. Let's get rid of this, and then I'll just bring this in line like this. And then lastly, you have equals. You're going to have this 1 over. You have this x plus 1 quantity. Again, multiplied by the LCD. So 2 times the quantity x plus 4. Let me slide this down so it fits. Then times the quantity x plus 1. And again, I'm just going to cancel this now and remove it. So this is going to be canceled with this. I'm just going to get it out of here. just so it all fits nicely. So this 1 was multiplied by that. So this is just 2 times the quantity x plus 4. Okay. So now thinking about this, we just want to simplify and see where that leads us. So x and then minus. So this is where you have to be really, really careful. You are subtracting this whole thing away. So you might want to put some brackets here or parentheses or whatever, and then just do the result of this, and then you can distribute the negative to each term inside and then remove your brackets or parentheses. So x times x is x squared, and then basically you have 1x minus 7x, which is negative 6x, and then negative 7 times 1, that's going to be minus 7. So this guy right here would get multiplied by 2. Let me close that down. So this would be 2x squared minus 12x and then minus 14. Let's remove this and just drag this up here. Now, if you want to go through and simplify here, you're going to basically change the sign of everything. So this is going to be a minus, this is a plus, and this is a plus. And now you can get rid of all this and move this over. So basically you want to make sure that if you're subtracting something like this away, wrap it in parentheses or brackets or something like that so that you don't make a sign mistake. Okay, that's very important. Then this equals over here, you'll have 2x plus 8. Okay. Now thinking about simplifying here, on the left-hand side, I have x plus 12x. That's going to be 13x. So let me write negative 2x squared, and then basically plus 13x, and then plus 14. And this equals your 2x plus 8. I'm going to subtract 2x away from each side. We'll cancel that. I'm going to subtract 8 away from each side. We'll cancel that. So this is 0. So you're going to have negative 2x squared. And then 13 minus 2 is 11, so plus 11x. And then 14 minus 8 is 6, so plus 6. And this equals 0. All right, to make this a little bit easier, I'm going to divide everything by negative 1. And I'm just doing that so that the leading coefficient here is going to be a positive. I don't like factoring when it's negative, so you can just do this. This would give me 2x squared, and then minus 11x, and then minus 6, and this equals 0. Okay, let's solve this using factoring. Again, if you don't like this, you can just use the quadratic formula. So we have 2x, and then we have x. So basically, this is a minus here. So I'm going to be subtracting, okay? And I want to think about getting to 11 in terms of absolute value. Forget about the fact that it's negative 11. So for 6, it's 1 times 6 or it's 2 times 3. Now, I can't put the 6 here, okay, but I could put it here, right? You can't put it here because you have a common factor of 2. There's no common factor of 2 there. Does this work? Well, this is going to be 12 minus 1, which is 11. So this needs to be a negative, and this needs to be a positive, and that's what we want, right? This is negative 12x. This is x. And basically, negative 12x plus x is negative 11x. So this is what we want. And I didn't mean to do that. So let's come down here and say 2x plus 1 equals 0, or x minus 6 equals 0. So here we subtract 1 away from each side. We say 2x is equal to negative 1. Divide both sides by 2. We'll say x is equal to negative 1/2. Over here, let's add 6 to both sides. Let's cancel this. So also x could be 6. So let's grab these. So coming back up here, again, let's think about our domain. So what is the domain? So the set of all x such that x is not equal to, again, thinking about this, 2, you don't have to set that equal to 0, obviously. You just take factors with a variable. So x plus 4 gets set equal to 0. You solve that, you get negative 4. And then x plus 1 gets set equal to 0. You solve that, you get negative 1. So the domain is the set of all x such that x is not negative 4 or negative 1. Okay, you have negative 1/2 and 6. So you haven't violated the domain. So again, if you're on a timed exam, just move on, right? And you can come back later if you have time. But I'm going to check this and make sure that it works. Now, the benefit of negative 1/2, you can use negative 0.5 and just plug that into your calculator, and that should be pretty quick to do. So let's go ahead and do this in our calculator. So I'll say this is negative 0.5 over 2 times, you're going to have negative 0.5 plus 4. Let's just say that's 3.5. That'll be easier to punch in. And then over here, your negative 0.5 plus 1, that's going to be 0.5. And then we'll have minus. You can have negative 0.5 minus 7. Let's just go ahead and say that's going to be negative 7.5. This will be over. You have negative 0.5 plus 4. So we already know that's 3.5. And this should be equal to 1 over negative 0.5 plus 1 is 0.5. Now I know that 1 divided by 0.5 or 1 divided by 1/2 is 2. So I'm just going to erase this and put 2. You could punch this into your calculator and make sure you get 2. I'm just going to tell you in advance that you will get it. So I'll just let you punch that in on your own. Just make sure to wrap this in parentheses and this whole thing in parentheses when you're dividing, because if you don't do things like that, you're going to make a mistake and you're going to think that you got the wrong answer. So this will end up being 2 is equal to 2. Okay, so that's verified. So over here, now we have 6. So this is something pretty easy to work with. So you'd have 6 over 6 plus 4 is 10. And then over here, 6 plus 1 is 7. So 7 times 10 is 70, times 2 is 140. Now, you could cancel a common factor of 2 there. So this would be 3, and then this would be 70 here. Now, coming over here, you'd have 6 minus 7, which is negative 1, over, if you have 6 plus 4, that's 10. Now, what I would do here is say minus a negative is plus a positive. So I'll just say this is a plus here. And then essentially I would multiply this by 7 over 7. So this would be 7 over 70. So this would end up being 10 over 70. So 10 over 70, or 1/7. So this is 1/7. Then this equals, you have 1 over, again, 6 plus 1 would be 7. So 1/7 equals 1/7. So this guy is verified as well. So x here can be negative 1/2 or 6. All right, let's take a look at problem number 8 now. So we have 1 minus 7 over x is equal to, we have 6x squared plus 12x minus 18. This is over x squared plus 4x. So let's write 1 minus 7 over x. This equals, up here, let me pull out a 6. That would give me x squared, and then plus 2x, and then minus 3. And I could further factor that. If you want two integers whose sum is 2, and whose product is negative 3, well, that's going to be positive 3 and negative 1. So this is 6 times the quantity x plus 3 times the quantity. You'll have x minus 1. Okay, let's replace this with this. And I'm just doing this to see if anything's going to cancel. I think you can eyeball that and see it's not going to. But again, you have the unfactored form if you need to work with it that way. So I prefer to have both. So down here, I'll have x times the quantity x plus 4. Okay, so the LCD is obviously going to be x times the quantity x plus 4. You have an x here and an x here. And then here you have this x plus 4. All right, so we would multiply both sides of the equation, again, by this LCD. So this, if I multiply 1 by this, I'm just going to get it. So x times the quantity x plus 4, or again, you could just say it's x squared plus 4x. We might as well just do that because we're going to have to distribute it anyway. And then minus, you're going to have 7 over x times this x times the quantity x plus 4. Again, because it's hard to fit all this stuff on the screen, I'm just going to cancel stuff as I go and say this cancels with this. So you would erase this and say 7 times the quantity x plus 4. Let me slide this down here and then slide this down like this. Then we could say this equals, well, if this guy here gets multiplied by the denominator, well, then the denominator is going to cancel, right? So I would just have 6 times the quantity x plus 3, and then times the quantity x minus 1. So on the left side, let's say we have x squared, and then plus 4x. And then this negative 7 is multiplied by x, so that's negative 7x. And then negative 7 times 4, that's minus 28. And this equals, then for this one, we can go to our unfactored form. So that was 6x squared, and then we had plus 12x, and then minus 18. Looking at this, we can see we have a quadratic. So I'm just going to put this into standard form. So let's go ahead and subtract x squared away from each side. This will cancel. And then 4x minus 7x is going to be negative 3x. So let me just write here that this is negative 3x. I'm just going to line that out. And then basically I would add this 3x to both sides. And then I'll cancel this away. And then I'm going to add 28 to both sides. And then I'll cancel this away. So this is 0 over here. And I'm just going to flip the sides because I like my variable to be on the left. So I'll say 6 minus 1 would be 5. So this is 5x squared. And then 12 plus 3 is 15. So plus 15x. And then negative 18 plus 28 is 10. So plus 10. And this equals 0. So of course you could factor out a 5 or you could divide everything by 5. It's probably better to divide everything by 5 because then you don't have to think about it anymore. And so this would give me x squared plus 3x plus 2 is equal to 0. So this left side here would factor. This would be an x and this would be an x. And so essentially you would think about two integers whose sum is 3 and whose product is 2. So this is plus 2 and plus 1. So you have x plus 2 is equal to 0, or x plus 1 is equal to 0. So x is negative 2, or x is negative 1. So let me write this in a more compact way. So x equals negative 2 or negative 1. Okay, so coming back and thinking about my domain. So what is my domain? And I'll just say that it's the set of all x such that we see we have an x here. Again, you set that equal to 0, so x can't be 0. So x is not equal to 0. And then also x plus 4, this factor here would be set equal to 0. So if you set x plus 4 equal to 0, the solution is x equals negative 4. So you have negative 4 there as well. So the domain is the set of all x such that x is not 0 or negative 4. So again, just looking through this, I'm not violating the domain. So again, if you're in a hurry, just put that answer down and move on. Now again, to check this fully, I'm going to say this is 1 minus. If you go 7 over negative 2, you might as well say this is plus 7 halves. And then we could just say this is 2 over 2 here. And so basically this left side would be 9 halves. So this is 9 halves, or if you're doing this with your calculator, it's 4.5. And then over here, you think about 6 times, you'd have negative 2 plus 3, which is 1. And then times negative 2 minus 1, which is negative 3. And this is over, you have your negative 2 times your negative 2 plus 4, which is 2. Let me go through and fix this. This is a 3 here. So let's say that we have this 6 right here would cancel with, let's just say this 2 here, and that gives me a 3 here. So 3 times negative 3 would be negative 9. So this would be negative 9. And then down here, you just have the negative 2. Well, negative divided by negative is positive, so you'll just say that you have 9 halves equals 9 halves. So this is a verified solution. Now for negative 1, you have 1 minus 7 over negative 1. So again, this is minus a negative is plus a positive. So let's say this is 1 plus 7, which is going to basically be 8. Okay, so this is 8. That's what we're looking for. And then over here, you have 6 times negative 1 plus 3 is going to be 2. And then times negative 1 minus 1 is negative 2. This is over. You have negative 1 times, you have negative 1 plus 4, which is 3. Okay, so let's go through here. I'm going to cancel this with this and get a 2 here. So essentially, cancel this negative with this negative, and I'll have 2 times 2 times 2, which is 8, and so you get 8 equals 8. Okay, so this is 8 equals 8. So again, this is verified. So our solutions here, x equals negative 2 or x equals negative 1. Again, they don't violate the domain, and we also saw that the left and the right sides were equal. All right, let's take a look at problem number 9 now. So we have 1 minus, I'm going to factor this 2 out. So 2 times the quantity x minus 3. This would be over x, and this equals, up here, let's factor out the 3. That would give me x squared plus 7x minus 8. And then you could factor this further. If you want an x here and an x here, and 2 integers whose sum is 7 and whose product is negative 8, well, that's going to be positive 8 and then negative 1. Down here, you could factor that as x times the quantity x minus 5. Now, this is going to be your LCD, right? The x times the quantity x minus 5. Again, when you think about it, you have an x here and an x here, and then you have this x minus 5 there, okay? So coming down here, and again, it's really hard to fit this on the screen, but we're basically going to multiply this guy right here by everything in this equation. So if I multiply it by 1, I just get x times the quantity x minus 5, which I might as well just write as x squared minus 5x. Then minus. Here's where I'm going to put some brackets, or you could use parentheses or whatever. This is going to multiply by this, okay? So we know that the x's would cancel. So you're going to have 2 times the quantity x minus 3 times the quantity x minus 5. And again, this x right here is going to cancel with this x right here if x times the quantity x minus 5 is multiplied by this guy right here, okay? So I would have to simplify this, and I'll do that in a moment. Then this equals, again, if I multiply this guy right here by this LCD, or this denominator, well, the denominator is going to cancel. So I have the 3 times the quantity x plus 8 times the quantity x minus 1, which in unfactored form, again, was 3x squared plus 21x minus 24. Okay, let's see what we can do here. So over here, we have x squared minus 5x and then minus. So first I would say x times x is x squared. And then you would have your outer, which is negative 5x, your inner, which is negative 3x, so that's negative 8x. And then negative 3 times negative 5 is plus 15. Now, this is going to get multiplied by 2. Okay, so 2 times x squared is 2x squared. And then basically 2 times negative 8x is negative 16x. And then 2 times 15 is 30. So let me replace this with this. Now here's where those brackets really come in handy. This negative has to be distributed to each term here. Okay, so I'm going to drop this, and basically I'm going to change the sign of everything. So this becomes a negative, this becomes a positive, and this becomes a negative. Very important. Then this equals, you have 3x squared, and then plus 21x, and then minus 24. From here, let's think about on this side, x squared minus 2x squared would be negative x squared. Negative 5x plus 16x is going to be plus 11x. And then you have your negative 30 there. So this equals, over here you have 3x squared plus 21x, and then minus 24. All right, so let's get this into standard form. I'm going to add x squared to both sides. So that will cancel. I'm going to subtract 11x away from each side. So that would cancel. And then I'm going to add 30 to each side. So that would cancel. So let's write this as 0. And let's say that 3x squared plus x squared would be 4x squared. And then 21x minus 11x, that's going to be plus 10x. And then negative 24 plus 30 is going to be plus 6, and this equals 0. Now I can divide everything here by 2 just to make things a little bit simpler. So this would be 2x squared, then plus 5x, then plus 3, and this equals 0. Okay, so you could solve this with factoring if you want to. I think it's probably the easiest choice here. Again, you can always use the quadratic formula if you're not comfortable. So you could say this is 2x and this is x. 3 is a prime number, so it's really 1 times 3, or you really could do negative 1 times negative 3, but everything's positive here, so I would not consider that. If you put the 3 here, it's too big. So you'd have to put the 3 here and the 1 here. So basically, this right here would be 2x, and this would be 3x, and 2x plus 3x would give me 5x. So this is good to go. So I would say that 2x plus 3 is equal to 0, and I would subtract 3 away from each side and say 2x is equal to negative 3. Divide both sides by 2. We'll say that x is equal to negative 3 halves, right? You could say negative 1.5 if you want. So that's one solution. The other one, I think we can eyeball and see it's negative 1, but for completeness, let's say x plus 1 is equal to 0. Subtract 1 away from each side, and so x could also be negative 1. So let's go back and check. So again, what is my domain before we continue? So the set of all x such that we know x can't be 0. And the other guy, x minus 5, if you set that equal to 0, we get x is equal to 5, so x also can't be 5. So this is my domain, right? The set of all x such that x is not 0 or 5. Here you got negative 3 halves, which is negative 1.5 and negative 1. So we're good to go. We didn't violate the domain. So let's just plug in and check. So we'll say 1 minus 2, and you can use the negative 1.5. I would advise that here. If you do negative 1.5 minus 3, that's negative 4.5. And if you do that multiplication, you're going to get negative 9. So this is negative 9, and this is over. You're going to have this negative 1.5. Now, if you do a negative over negative, it's a positive. So let me erase this and this. Now 9 divided by 1.5, that's going to be 6. So basically you have 1 minus 6, which is negative 5. So this is the left side, negative 5. Over here, you're going to have 3 times, let me just plug this in. So negative 1.5 plus 8. And then over here, negative 1.5 minus 1. And then over here, negative 1.5 times the quantity negative 1.5 minus 5. Okay, so negative 1.5 plus 8, that's going to be 6.5. So this is 6.5. Negative 1.5 minus 1, that's negative 2.5. So this is negative 2.5. Down here, negative 1.5 minus 5 is negative 6.5. So this is negative 6.5. Now, you can see that this guy would cancel with this guy, and you just have the negative, okay? And then basically, you have 1, 2, 3 negatives, so you might as well just say this is going to be a negative, right? And you think about 3 times 2.5, that's 7.5, and then divided by 1.5, and you're going to get 5. But again, it's 1, 2, 3 negatives involved, so you're going to have a negative 5. So this would be a negative 5. Okay, so the left and the right sides are equal, so this guy's verified. Now for negative 1, I think it's a little bit easier. So you have 1 minus, you're going to have 2 times, negative 1 minus 3 is going to be negative 4. This would be over your negative 1. So 2 times negative 4 is negative 8. So you have negative 8 divided by negative 1, which is 8. So 1 minus 8 is going to be negative 7. Now this should be equal to 3 times, you have negative 1 plus 8, that's going to be 7. Then times negative 1 minus 1, that's going to be negative 2. This is over. You have negative 1 times, you have negative 1 minus 5, which is negative 6. Can I cancel anything? Well, I can. Think about 6 divided by 2 is 3. So let's cancel this and say this is a 3, and this is gone. And then I can cancel this 3 with this 3. So essentially what I have here, again, the 3 negatives. So a negative here divided by a negative here is a positive, and then you have this negative here, which is going to change the sign. So essentially you're going to have negative 7 is equal to negative 7. So this is going to be negative 7 equals negative 7. So we get negative 1 is verified here. All right, let's take a look at problem number 10 now. So we're going to have x plus 5 over x minus 4, then plus 1 over x minus 4. This equals 7 over x squared minus 4x. Let me rewrite this. So x plus 5 over x minus 4, then plus 1 over x minus 4. This equals 7 over, I'm just going to factor this and say this is x times the quantity x minus 4. And then essentially thinking about what we have here, the LCD is just going to be this x times the quantity x minus 4, right? You have x minus 4 here and here and here, but it only occurs once in each case. And then you have this x here. So my LCD would be this guy right here. Let me do that in a different color. So this x times the quantity x minus 4. All right, so let's multiply everything by the LCD. And so I think I can write it out here. It's pretty small. So x times the quantity x minus 4. Then we basically have times this x plus 5 over this x minus 4. You could wrap this if you want. Then plus 1 over x minus 4. Then times this x times the quantity x minus 4. And this equals 7 over this x times the quantity x minus 4. Let me make this 4 a little bit better here. And this is times this x times the quantity x minus 4. So let's cancel this with this. You can have x times the quantity x plus 5. So that's x squared plus 5x. And then plus, over here, this would cancel with this. So you have x times 1, which is just x. And this equals, over here, this would cancel with this, so you just have 7. All right, so 5x plus x is going to be 6x. So this is x squared plus 6x. I could subtract 7 away from each side. So then minus 7, this equals 0. You could solve this one using factoring. It's not too bad. So this is x and this is x. Two integers that sum to 6 and have a product of negative 7. Well, that's going to be positive 7 and then negative 1. So here, you would set x plus 7 equal to 0. So x is equal to negative 7. And then also you would set x minus 1 equal to 0. So then x is positive 1. All right, so for my domain, let's put this off to the side here. It's the set of all x such that x is not equal to. If you set x minus 4 equal to 0 and solve that, you would get an x value that's equal to 4. And then also you would set x equal to 0, so that would just be 0. So it's the set of all x such that x is not equal to 4, and then also it can't be equal to 0. Now here you have negative 7 and 1, so we're not violating the domain. Now to completely check your answer and make sure you didn't make some silly mistake, you just plug in. So let's start with negative 7. So negative 7 plus 5 is negative 2. This would be over. Negative 7 minus 4 is negative 11. So this is basically 2 over 11. And then plus, if you have 1 over, you would have negative 7 minus 4. That's going to be negative 11. Let me move this up into the numerator. So basically 2 minus 1 is 1, so this would be 1 over 11. Okay, so this is 1 over 11, and this equals, over here you have 7 over. You have negative 7, then times the quantity, negative 7 minus 4. So negative 7 minus 4 is going to be negative 11. So negative times negative is positive. So let me just cancel those out, or you could actually just erase them if you want. And then basically you can cancel this 7 with this 7 and put a 1 up there. So this is 1 over 11 as well. So 1 over 11 is equal to 1 over 11. So we have verified that this is a valid solution. Okay, let's check 1. I think that'll be actually a little bit easier. So 1 plus 5 is 6 over 1 minus 4 is negative 3. So 6 divided by negative 3 is negative 2. Then plus, you have 1 over. You have 1 minus 4, which is going to be negative 3. So basically for this one, let's go ahead and say, I'll shift this up here to a minus. So I'll put this negative 2 as negative 6 over 3. And then negative 6 minus 1 is negative 7. So this is going to be negative 7 over 3. Let's set this equal to 7 over. You have 1 out here. You can just get rid of it because it's multiplication. And then 1 minus 4 is going to be negative 3. So you can move this out in front like this, and you can move this out in front. So basically negative 7 over 3 is equal to negative 7 over 3. So this one works as well. So our two valid solutions here, x equals negative 7, or x could be 1.